The last section we're going to finish up with is 7.4. And 7.4 is on simplifying trig equations, expressions, identities. Basically, if we've got something that has multiple trig functions in it like that, the goal is to try to make it as simple as possible. The reason for doing that, you'll see more in calculus, but if we have to do some calculus with this expression, it's kind of complicated because there's two different trig functions and there's a fraction. There might be a way we can write that in a simpler way, so before we get to the calculus part of the problem, it's easier. Right? So that's kind of the goal of trig identities. So first, just a reminder, an identity is an equation that is true all of the time. So these formulas that we're going to be manipulating are not formulas that only work for certain values. Okay? They work for all values. So there's some identities we should already be familiar with. Okay? The reciprocal identities, like if you flip sine, you get cosecant, cosine, you get secant, tangent, flip that, you get cotangent. Also, we haven't done these yet, so I'm going to write those down. But the tangent and cotangent identities, does anybody remember how you can write tangent as a fraction of two other trig functions? Yeah?
Isn't it cosine or sine over cosine?
Sine over cosine. Okay, that's the tangent identity.
And then when cotangent would be the opposite?
Yeah.
So it's cosine over sine?
So cotangent is cosine over sine. So we've done that one, and that one. The ones we haven't done yet are the Pythagorean identities. Right, so I'm going to write those down. There's the tangent and cotangent. I just wrote those above. Okay. Page 403, that has all the different identities that we've talked about so far. Okay, let me, actually, you know what? I think I have a page. Okay, so there's all the identities we've done so far. Reciprocal, the quotient identities known as the tangent and cotangent, but it's the Pythagorean identities that I have not given you yet. Okay, so these are new, and we want to write these three down. So the Pythagorean identities all have something to do with an exponent of 2. Okay, just like when you do the Pythagorean theorem, a squared plus b squared equals c squared. And these identities are going to be used whenever when we see exponents of 2. Hopefully we're going to be able to simplify that using one of these identities. So that's kind of a hint when you need to use a Pythagorean identity. A lot of times when you see an exponent of 2 in the problem. So the first one is sine squared plus cosine squared equals 1. The next one is 1 plus tangent squared equals secant squared. And the last one is 1 plus cotangent squared equals cosecant squared. Now, you really only have to remember the first one. Sine squared plus cosine squared equals 1. If you take everything in that and divide it by sine squared, watch what happens. Sine squared, sine squared, sine squared. What's sine squared divided by sine squared? Yeah?
1.
1. Now, we have cosine squared over sine squared. Well, we already know what cosine over sine is. Cosine squared over sine squared is pretty much the same concept, just to a higher power. So what do you think cosine squared over sine squared is? Yeah?
Cotangent. Oh, good.
No.
Cotangent squared.
Cotangent squared. Yep. So cotangent squared. And 1 over sine squared. Well, we already have 1 over sine is cosecant. So what do you think 1 over sine squared is?
Cosecant squared.
Cosecant squared, yeah. And if you look at that one, 1 plus cotangent squared equals cosecant squared, that's the last one right there. All right. So if you divided everything here by cosine squared, you could get that one. Right? So if you can remember sine squared plus cosine squared equals 1, you can figure out the other two if you have to. Okay. All right, any questions on that? So now the whole thing that we do with trig identities is basically substitution. We look at the problem they give us, and we try to substitute in one of these identities to hopefully cancel something out. Okay, that's the goal. I already kind of explained that to you. And here is one trick that we use a lot to simplify identities. That trick is to change everything in the problem to sines and cosines. Every trig function can be written with just sines and cosines. And a lot of times when you do that, you will get things that cancel out. Okay. Now, one thing about this process, it is not the same ever. There's so many different kinds of problems. It's kind of like if I was trying to teach you how to do word problems. Like, I can't teach you how to do every kind of word problem you're ever going to come across. Okay. Same with identities. There's a lot of similar situations that come up, but I still can't show you how to do every single type of problem you could ever have. Okay. All right, so let's try our first one. And the hint is going to be to change anything in the problem that's not sine or cosine into sine or cosine. Okay, so let's start with that one. Cotangent divided by cosecant. How can I rewrite cotangent so that it's in terms of sines and cosines only? Yep.
Cosine over sine.
Okay, so we can make that cosine over sine. By the way, the letter that you use right there to represent the angle, that's just a variable. That doesn't really matter.
Theta.
Yep. And now we're going to divide by cosecant. How can we use one of the identities from the other page to rewrite cosecant just in terms of sine or cosine? Yep.
Isn't cosecant cotan plus 1? Or cotan squared plus...
No squareds in this one.
Cosecant is 1 over sine.
1 over sine. Yep. All right. And now when we divide the two fractions, yep.
Well, since they're both over sine, wouldn't they simplify down to cosine over 1?
Yep.
Which is just cosine?
So if you keep the top the same and then change it to multiplication and flip the bottom, you have cosine, oops, I wrote the final answer, but you have cosine over sine in the top. Flip the bottom, you have sine over 1, and when you multiply, if you have the same thing in the top and the bottom,
Cancel.
they cancel out, and what's the only thing you're left with?
Cosine.
Cosine. So now, if you have to do something with the expression cotangent divided by cosecant, a much simpler version of that is to just use the cosine. So we got it down to one trig function with no fraction in it at all. That's basically what we're doing today. They get a little harder, but that would be considered kind of an easier one. Any question on what we did there? Basically, all the properties you can use in algebra, factoring, distributive property, combine like terms, all of that stuff can be applied to these kinds of problems. All right, let's try another one. Let's try cosecant times tangent. All right. Again, changing everything to sines and cosines, it will generally always work. It might not always be the fastest way to do it. In the last problem, I would say, yeah, that was definitely the fastest way to do it. Okay. Start with this one. What could I change cosecant to? Yeah?
1 over sine.
We can make that 1 over sine times. What can we change tangent to? Yep.
Sine over cosine.
Sine over cosine. and now we're multiplying straight across. What happens when we multiply? Yeah?
Signs cancel.
Signs cancel out. We're left with 1 over cosine. And now it's a question of how do you know if you should stop there or not? Well, I would say if you can write something not as a fraction, that's simpler than having a fraction. So what is 1 over cosine not as a fraction? Yep,
Secant.
secant. So again, we took something that had 2 trig functions to start with, and it had a multiplication between them. And we condensed all of that down to 1 trig function, just secant. It does not always kind of simplify down to 1 trig function. That doesn't always happen. But so far it did. Any question on that one? Okay. So there's a difference between simplify an identity, which is what the first two were, and then verify. The difference with verify is you start with something on the left, you start with something on the right, and you generally start with the more complicated side, and you try to simplify it until you get the other side. So with a verify problem, you kind of know when you're done. You have what you're starting with, and then you have what you want to end with. You just have to figure out how to get there. Okay. With simplify, you don't really know where you're supposed to end. You just have something to start with, and you work with it as much as you can until you think you're done. So simplify can be a little harder because you don't know what the end goal is supposed to be. Verify, you do. Okay, and that's the approach that we're going to do. When they ask you to verify something, pick the more complicated side in the problem. Okay, so like if I was looking at this one, I would say the right side is definitely more complicated. In that one, I would say both sides are about the same. So it wouldn't matter which side I start with. But if there is clearly a more complicated side, take that one and simplify it as much as you can until you get the other side. Now, the other approach you can do, which I'm probably not going to in the ones we do today, you can work with both sides at the same time. So like you do a little bit of simplifying on the left, you do a little bit on the right, and eventually you get them to be the same on both sides. But that's the goal. You've got to get the left and the right side to be the same. Okay, and I'm generally going to stick with the top method. Okay. Any question on that? All right, so changing everything to sines and cosines, that's one trick we can use. Another trick is if you have fractions and they don't have a common denominator, find a common denominator. And a lot of times when you rewrite things with a common denominator, something will cancel out. Now, one thing that does come up quite a bit when you're doing common denominators are the Pythagorean identities. Okay, those tend to come up pretty often. All right, let's try a problem. Okay, we're going to do another simplify first, and then we'll do a verify after. Okay, so it's sine times cotangent plus tangent. All right. Now, there's something I can do here that you learn in Algebra 1, a certain property you can use. Anybody have an idea what property I'm going to use in this problem? Yep?
Distributed.
Yeah. I'm going to use the distributive property. So I'm going to distribute out this first. If you were thinking change to sines and cosines, that's okay too. You need to do both. I just generally do the distributive property first, and then I change to sines and cosines second. But eventually you're going to do both. sine times cotangent, and then sine times tangent. Okay. Now let's change to sines and cosines and see what happens. Okay. Sine is already sine, so we don't have to change that. How about cotangent? How can I rewrite that?
You can rewrite that as cosine or cosine.
Cosine over sine. Okay, sine is already sine, so we leave that one. And how about tangent? How can I rewrite that one? Yep. Sine over cosine. Now, there is something we can cancel out. We just have to be careful. Does anybody see what it is that's going to cancel out? Yep.
The two signs on the left.
Right, the two signs on the left. You can always cancel if you have the same thing in the top and the bottom, if it's multiplication. You cannot cancel something from the top and the bottom across a plus sign. Try it with numbers. Plug numbers in for all of those. You can't cancel the numerator of the cosine here and denominator of cosine over there. That doesn't work. So don't cancel across a plus or a minus sign. Multiplication, that's fine. So now we've got cosine over 1 plus, what's going to be my other fraction on the right? Yep.
Sine squared of theta over cosine of theta.
Yeah. Okay, so now we've written everything in terms of sines and cosines, but there's still a little bit more we could do. So what's the other trick that I just mentioned, but we haven't tried it yet?
Find a common denominator.
Yeah, find a common denominator. So let's put these together. My two denominators are 1 and cosine. What's the common denominator between 1 and cosine? Yeah? Cosine. Yep. So let's change that to cosine. So 1 and cosine. So put the denominator of cosine. Now, did either one of those fractions already have a denominator of cosine?
Mm-hmm.
Which one?
Sine. Sine squared.
Yeah, the sine squared. So that one already had the cosine, so it doesn't need to change. This one on the left does not. What would we have to multiply the fraction on the left by to make the denominator there? Cosine. Yep.
Multiply by cosine.
Right. You have to multiply the top and the bottom by cosine. Now, cosine times 1 is cosine. What's cosine times cosine? Yeah. Cosine squared. Now, there's something there that we need to recognize. And it was on the identities that I put up at the beginning. Yeah?
Is the Pythagorean, I forget what it's called, Pythagorean identities.
Yeah, there's a Pythagorean identity there. Yeah?
So the top equals 1.
Top just equals 1. Right? We wrote it as sine squared plus cosine squared, but you can take that and you can write it different ways. Right? You could write it like this. If you wanted to bring something to the other side, bring the sine squared over. So we have to kind of get used to seeing those Pythagorean theorems rearranged with things on different sides. Okay? But this one, they're still on the same side, they're just in a different order. Sine squared plus cosine squared plus sine squared, same thing. So that entire numerator turns into 1. And what is 1 divided by cosine? Yep.
Secant.
Secant. Okay, so we started out with something that was very well, relatively complex. We had a distributive property with 3 different trig functions. And when we simplified that whole thing, it turned into just secant. Okay? So secant is a much simpler thing to work with than all that stuff that we started out with. And it's exactly the same thing. They're the same thing, it's just a simpler version. Okay, so that one's a little bit harder, not necessarily the hardest one we're going to do, but not as easy as the first 2. Any questions on that one? Okay, and a lot of times I'm making them look easy because I'm kind of guiding you through what steps to do, but it does take a little practice to get good at them. Okay, let's try this one. All right, so let's start first verify. We already know what the result is we want to get. When we're done, that whole right-hand side is supposed to turn into sine. So if you don't get sine on the right, then you know something's wrong. Okay. Now, I'm just assuming that we are going to work with the right-hand side. You want to work with the more complicated side, which in this case I think is the right. Okay. So I'm going to write down the right-hand side. Secant over tangent plus cotangent. Okay, the other thing about identities is there's often more than one way to do it. Okay, somebody may start with a certain step, you may start with a different step, and you could still end up with the same result. Okay. The goal is to try to find the most efficient way to do it. That would be nice. But as long as we simplify this and end up with sine, then that's the goal. Okay. Any thoughts what we could do with this one? There's no step in this problem we haven't done before. We just have to try the different steps that we've been using all along. Yep.
Turn them all into sine and cosine.
All right, let's try changing everything to sines and cosines. Always a good place to start and see what that does for us. So we have 1 over cosine, and then we've got sine over cosine, plus cosine over sine. Okay. Can you cancel out the sines and cosines in the bottom?
No.
No, that's across the plus side. You definitely can. If that was multiplication, that would be a very easy problem, but it's not. Okay. All right, so we changed everything to sines and cosines. What else could we do? Yep.
You can multiply the bottom flipped. How do I describe it?
There is something we want to do with the bottom, something we've done before. What is it we could do with the bottom? Yep. Multiply both sides. Well, we only have one side. We're only working with the right-hand side. So something I want to try to do with this. Not going to do anything with the top for quite a while. Yeah?
Find the common denominator.
Find a common denominator. Yeah, we have 2 separate fractions. Let's put them together. So we have 1 over cosine divided by, what's going to be the common denominator in the bottom? It's the same way you do it with numbers. No different. Yep.
Cosine or sine, but I think cosine would be better.
So what's the common denominator here?
It's 21.
21. How'd you find that?
By multiplying.
Multiplying
3 by 7.
3 times 7. So let's do the same thing here. Multiply sine and cosine together. can just write it as sine times cosine or cosine times sine. You can write it either way. So sine times cosine. So multiply your two denominators together. What is the denominator on the left missing to make it the common denominator? Yep, it's missing sine. So we're going to multiply by sine over sine. And what's the denominator on the right missing to make it the common denominator? Yep, cosine. Just like multiplying this fraction by 7 over 7 and this one by 3 over 3. It's exactly the same thing, just we're not using numbers. Okay, so cosine over cosine. And so I got my denominator, sine times cosine. What does that give me in the top? Yep. Sine squared plus cosine squared. That's always a good thing. Because what is sine squared plus cosine squared? Yep.
1.
1. So now I have 1 over cosine divided by this all turns into 1 over sine times cosine. Now I have a fraction divided by another fraction. How do we divide two fractions? Yep.
You flip the bottom one and multiply.
Yeah. Flip the bottom one. So 1 over cosine. Top stays the same. Flip the bottom one and multiply. Sine times cosine over 1. And now when we multiply there, what's going to happen? Yeah.
The cosines are going to cancel out.
Cosines are going to cancel out. And what are you left with?
1 times sine over 1, which is just sine.
Which is just sine. And remember, that's the right-hand side. Okay. What was it we were supposed to get on the left-hand side?
Sine.
Sine. That's exactly what we were supposed to get. So we proved that the right-hand side is the same as the left-hand side. And we know we're done because we get the same result that they told us to get. Sine. Okay, so that's a verified problem. Okay. Any questions on that? All right, so as long as you really understand what you're doing when you do arithmetic and algebra, this is really the same kind of thing, right? If you don't really understand how to find common denominators by multiplying each fraction by the other denominator, then it's going to get kind of confusing, right, when you do it without numbers. But it really is exactly the same process. Common denominators, distributive property, it's all the same. We just sometimes end up with something with trig that's very nice that we have a formula for, and then we can simplify it based on one of those identities at the beginning. All right, so a third trick to simplify identities is to multiply by the conjugate. Okay, we've used this trick before. We've used it when we've had complex numbers. When you have something like 3 divided by 2 plus I, the way that we simplify that is multiply top and bottom by 2 minus I. That's the conjugate. You're going to know to use the conjugate when you have something kind of like that set up. Maybe like a single term and then something plus something in the bottom, or something plus something in the top and then a single term in the bottom. So basically something that looks kind of like that. That's a problem that kind of says conjugate right away. First of all, if I look at what's on the left, I see 1 minus sign. And if I look at what's on the right, I see 1 plus sign. So I already see conjugates in the original problem they give me. So that's a hint that that's what we're going to want to try. Changing things to sines and cosines wouldn't help. It already is. Finding a common denominator on the left or the right, well, that wouldn't help either because you don't have two separate fractions on the left side or two separate fractions on the right. It's one big fraction on both sides. So the only trick we have left is the conjugate. Now I said to always start with the side that looks more complex. I would say in this case, both sides pretty much look like they're the same complexity. So you could start with either side. Right? Unfortunately, it doesn't really look like we're going to get a lot of simplification here. It's basically going to turn into something that looks kind of similar to what you started with. Right? But they want us to manipulate it in. All right, so do we want to start with the left-hand side or the right-hand side? Which side do we want to start with? Yep.
I guess we'll start with the left.
Left? Okay. So our goal is to manipulate the left-hand side until we're done and it turns into the right. So let's copy that down. Cosine t over 1 minus sine t. All right. So what's the trick that you think we're going to use here? Yeah?
Multiply top and bottom by the conjugate.
Yes, we're going to multiply top and bottom by the conjugate. And when you do that, you don't want to do everything out. You want to do some of it out, and some of it you don't want to do out. Okay, I'm going to show you why. So we're going to multiply by 1 plus sine over 1 plus sine. The top you don't want to do out. We're going to leave that as a distributive property. Cosine times 1 plus sine. The bottom we want to do out. The reason you don't want to do the top out is because when you multiply conjugates together, it is usually going to cancel something that's in the top. So it doesn't make sense to distribute something out that's going to be canceled in this step anyway. Right? You wouldn't know that at first, but now you know. Okay, so when you see conjugates, leave the top the way it is, but multiply the conjugates together. Okay? And that has to be FOILed. Okay? So 1 times 1 gives me 1. How about 1 times sine?
Sine.
Sine. How about 1 times negative sine?
Negative sine.
Negative sine. Okay, so those cancel out. Positive sine, negative sine. What's negative sine times positive sine?
Negative sine squared.
Negative sine squared. Okay. So now there's something there we need to recognize as an identity that we wrote down. Yep.
Pythagorean identity.
Yes, there is a Pythagorean identity there. It's not written the way we originally put it on the board. It is rearranged a little bit. But does anybody see where the identity is and what it would turn into? Yep.
1 minus sine squared equals cosine squared.
Yeah, I might have written that down. Yeah, right here. 1 minus sine squared is cosine squared. So that entire bottom turns into cosine squared. Cosine 1 plus sine over cosine squared. Now the top and the bottom have something in common. What do they both have in common? Yep.
Cosine.
1 cosine. The bottom has 2. Cosine times cosine. The top has 1. So you can cancel 1. 1 from the top, 1 from the bottom. You're left with 1 plus sine in the top, and you are left with cosine in the bottom. And if you scroll back up and look at the right-hand side, 1 plus sine over cosine. 1 plus sine over cosine. So again, is it worth really doing that? Maybe not.
I
There's not really a lot of simplifying that happened there.
Figured it out without using the conjugate.
But yeah, and yeah, there's definitely other ways to do this one. Okay. But the important thing is, I think, understanding the concept of using the conjugate. That's what's important, because there are times when you use it and it will simplify. It'll make things a lot easier to work with. Okay. Any question on that one? Let's try a bunch of them. Let's try that one. Tangent squared minus 1 divided by secant squared equals tangent minus cotangent over tangent plus cotangent.
The tangent can have a x on the left side.
The tangent doesn't. Oh yeah, I should put the x in there. Yep, thank you. Okay, you might think that this top is a Pythagorean identity. It looks like an identity almost, but it's not. The identity is 1 plus tangent squared equals secant squared. The 1 and the tangent, if they're on the same side of the equal sign, have the same sign. They're both positive. Here, one's positive, one's negative. So even though it's kind of close to an identity, it's not. All right, so we can pick what side we want to try to work with. Anybody have a thought of which side maybe looks more complex? Yeah?
You're right.
Yeah, I think the right side looks more complex. It's got 4 trig terms in it rather than just 2 on the left. All right, so let's try working with the right and see what we can do. Tangent x minus cotangent divided by tangent plus cotangent. Okay. So there's a couple ways we can try to do this one. Yeah?
Isn't this, because you can cut off the 2 tans and get negative cotan x plus positive cotan x top and bottom, because tan divided by tan cancels out. Right?
No.
Not when you're adding or subtracting something to it. Order of operations, you need to do this first, then do this. So you really wouldn't have tangent and tangent anymore. It's being modified by cotangent. Yeah. All right. Any other thoughts what we could do with that right-hand side? Yep. Okay, you could change everything to sines and cosines. And there is a way to make that work. I will tell you it's probably more steps than the way I'm thinking of. All right. So this problem kind of, I guess, maybe breaks the rule a little bit, and we're going to try something different that's going to be faster. And what I'm focusing on is I'm looking at the top here, and I'm looking at the top there. And I'm trying to think, is there something I could do to the top that would make what's circled in blue on the right exactly the same as what's circled in blue on the left? Now, if I do that to the top, I also have to do it to the bottom. I haven't thought about what's going to happen in the bottom yet. I'm just trying to think, can I make the top on the right the same as the top on the left? And then we'll see what happens to the bottom after. Yep.
You can multiply by cotangent on both the top and the bottom. Which would
We can
change
multiply by,
cotangent of x. Negative cotangent of x. Oh, and on the other fraction.
Not that far. I do like the idea of multiplying by something. Yeah?
Multiplied by tan of x plus cotangent of x on the.
Okay, then let's focus down even more. How would you make that look like that?
Multiplied by tangent.
Just multiply by tangent. So let's just see if we just try to force this to look like that. Let's see what else happens in the whole problem. So to force what's circled in green here to look like what's on the left, multiply it by tangent. But if you do it there, you have to do it in every spot. And the hope is that something nice will happen. Okay, so let's see. So we're going to multiply by tangent over tangent. So we're going to distribute it. What's tangent times tangent?
Tangent squared.
That gives me tangent squared. And then tangent times cotangent. Those are reciprocals. That's like multiplying 5 1/5 or 3 1/3. When you multiply two reciprocals together, what do you get? Yeah? 1. So by making the first term look like what we wanted, it also automatically made the second term look like exactly what we wanted. Okay? So now we've turned the top exactly into what we wanted from the other side. What's going to happen in the bottom? I don't know. I haven't thought that far ahead yet. Okay, so I made the top the same. Now let's see what happens in the bottom. What's tangent times tangent? Tangent squared. And what's tangent times cotangent? 1. And now there is something there we can recognize. Yep?
One of the identities, which is tangent squared plus 1 equals secant squared.
Yeah. Tangent squared plus 1 equals secant squared. That bottom is a Pythagorean identity. So the top is tangent squared minus 1, and the bottom turns into secant squared based on the identity. And we're really done that entire problem in 2 steps. If you had changed everything to sines and cosines, it definitely would have been a lot longer. But it's still doable. Let me see. Let's try changing it to sines and cosines. I hadn't thought about how to do it that way, but let's try it and just compare it to what we just did. Okay. So that's that way. Okay. Now let's try sines and cosines. So we're going to have sine over cosine minus cosine over sine. So that's the first part. And then in the bottom, sine over cosine. And then plus cosine over sine. Yeah, that's okay. Okay, so that's what we get if we change everything to sines and cosines. Any question on that part? Okay, so lots of sines and cosines. Now, what do you think we should do in the top and the bottom? Yeah.
Multiply by the conjugate?
Usually conjugate is when we have like 1 plus something or 1 minus something or like a number plus a trig function. We don't really have that format in the problem that we're doing. It's a little different. Yeah?
Find common denominators.
Yeah, let's find common denominators in the top and the bottom. What's going to be the common denominator in the top? Yeah.
Cosine times sine.
Okay, so we're going to have sine times cosine. And what's going to be the common denominator in the bottom? Yeah,
Same thing.
same thing. So sine times cosine. Okay, when we do that in the top, yeah?
And those subsequently cancel out because they're the same if we divide it by.
Yeah, so we'll take a look at what's going to happen with that. But what do we have to multiply the top and the bottom by for this first fraction? Yep,
Sine.
sine. So that's going to become sine squared minus. And what do we have to multiply top and bottom by in the second fraction? Yep.
Cosine.
So cosine squared. And now we're going to do the same thing in the bottom. So in the bottom we get, let's see, multiply top and bottom by sine. That's sine squared. Multiply top and bottom by cosine. We get cosine squared. Okay, the only place I see something kind of good happening is this sine squared plus cosine squared. What does that turn into? Yeah?
1.
Okay, that turns into 1. Don't like the top. That's not looking great. So it's sine squared minus cosine squared over sine times cosine all over 1 over sine times cosine. Okay. Now, because we are dividing two fractions with the same denominator, these denominators would cancel out. Okay, and now we're left with sine squared minus cosine squared, which I'm not crazy about having that. So it would be at this point, if I was solving it this way, that I would say, no, I don't like this method. Either I made a mistake, which I don't think we made a mistake, or I'm getting to a point where I don't like where this method is going. It's not that I couldn't continue down this road and just kind of brute force it until I figure it out. It's just not working out very elegantly, so I would have tried a different approach at this point. And I don't really want to spend a lot of time trying to figure out how to do it this way, because we already figured it out the first way. All right. Yeah.
It's convoluted.
Yeah, it's just getting kind of messy. So if you start doing it, this is a good example. If you start doing it one way and it's not really working out, I would start again, but try a different method. Okay, try a different way to think about it. Okay. So any questions why I don't want to continue on this method anymore? I mean, you could always verify that you're okay up to this point, because if you graph this in y1, and then you put this in y2, you could at least check to see that they still look the same. If they don't, then you've made a mistake. If the two graphs continue to look the same, then you're fine. You're still on the right track. You're doing things that are working, but it might not be getting you to where you want to go. All right, let's try one more so we can end on a successful one. All right, let's try that one. That looks nice. It's supposed to simplify very nicely to negative cosecant when we're done.
Isn't that verified?
Yep, that's verified. So when we're all done, we're going to get negative cosecant. Okay. Any suggestions what we try to do first? Yep.
Simplify 1 over tangent of x to cotangent of x.
Okay, we could simplify it to cotangent. But remember, we do have to combine it with this one somehow. So the one on the right has sines and cosines. So it might be a good idea to make the one on the left also have sines and cosines. And I think that might help us. Yep.
The one left, which is equivalent to cotangent, is also equal to cosine over sine.
Okay, so let's start by making it cosine over sine plus sine over cosine minus 1. All right. What could I try to do with those two fractions now?
You could take the sine away from both sides. But no, it's not multiplying.
No, you can't cancel out the sign there. I see two paths that I'm considering, but there's too many steps in the paths for me to figure out the answer out all the way to the end, so I'm not sure which one.
Find the common denominator.
Okay,
by
so we
multiplying
could,
the bottom.
yep, we could find a common denominator, so that's one thing we could try. What's the other thing we could try? Yeah?
Take the conjugate.
Yeah, we could try just manipulating this part by multiplying top and bottom by the conjugate. I don't know. Let's try finding a, I guess I don't know. Let's try a common denominator and see what happens. So common denominator is sine times cosine minus 1. Let me write that a little nicer. Sine times cosine minus 1. What would we have to multiply top and bottom of that fraction by to get the common denominator? Yep.
Cosine minus 1.
Yep. So we have cosine times cosine minus 1 plus, okay, what would we have to multiply top and bottom of that fraction by?
Sine x.
Sine x. Yep. So we have sine x times sine x. And that's okay. I see some good things maybe happening here. So that's good. Let's distribute this out. What's cosine times cosine?
Cosine squared.
Cosine squared. Okay, so cosine squared. What's cosine times negative 1?
Minus cosine.
Minus cosine. And then
Sine squared.
sine squared. Over, let's see, sine x. Do I want to distribute that?
I think it goes.
I'm just going to leave it for now.
Yeah, it goes nicely.
Sometimes if I start doing out one part of the fraction, I don't want to start changing everything at the same time. I'll just leave the other part the same and see if I keep working with part of the fraction, if something cancels out. Because sometimes it's easier to not keep changing everything at the same time. Now we have something in the top that's going to work out nicely. Yeah?
Pythagorean identity, which would simplify it to 1 minus cosine of x.
Yeah. So we have cosine squared plus sine squared. Those two things that I just circled turn into 1. So now in the top, you have 1 minus cosine of x, close to what's in the bottom, but we're going to get it. We're just about there. So we have 1 minus cosine squared, cosine in the top, and we have sine times cosine minus 1 in the bottom. How could I make the top that's in parentheses look like the bottom that's in parentheses? I'd have to factor something out. Could I factor out of the top? Yep.
Factor out -1.
Factor out a -1, and watch what happens in the top. Now you have -1 plus cosine, and in the bottom, you have sine times cosine minus 1. Those two things in parentheses now are exactly the same. Cosine with a -1, cosine with a -1. So now you're left with -1 over sine.
We'll pass out the negative cosine, or so cosecant.
What does it simplify to?
Negative cosecant.
Yeah. The -1 is confusing you in the top, then put it in front.
Just simplify it to a negative symbol.
Think of it like that. Okay, it's -1 times the reciprocal of sine. The reciprocal of sine is cosecant with a -1 in front. Okay, so negative cosecant, and that is exactly what we're supposed to get. Okay, is that the fastest way to do that one? I don't know, I'm not sure. It wasn't awful. It was maybe like 4 or 5 steps. If it starts to turn into like 10 or 15 steps, that's probably too many steps for the kinds of problems that I'm going to give you. You know, that's about the difficulty you would probably see at like the hardest. Now the other option here would have been to multiply top and bottom by the conjugate, just of this fraction. Maybe that would have been faster. I don't know. I'd have to try it. All right. So that's trig identities. All right. Any questions on that last one? All right. So definitely the kind of thing does take a little practice. Okay. So there's not a ton of them to do because some of them can take a little bit, especially if you start going down the wrong road with it. So we got 4 through 8, 11, 12, 21, 22, and 25 to 27. Okay. On 21 and 22, it says to graph them. You don't have to graph them. Just do it the way we've been doing it in class. They're all the same problems similar problems we did in class.